Welcome to ChargingStack, where we explore the ideas and technologies reshaping how we move on land and water. Joining us today is Mikael Mahlberg, head of PR and communications at Candela, the Swedish company reinventing boats with electric hydrofoiling technology. And he's here to share how Candela is making water transport cleaner, faster, and more efficient, from leisure craft to city ferries. Mikael, welcome to ChargingStack. It's great to have you here.
Thank you for having me on the podcast.
Absolutely. I would like to start with your origin and the mission. So Candela's mission is to take fossil fuels out of the water. What was the first thing that got you to chase that idea?
Right. So Candela, our mission is to speed up the transition to fossil fuel free waters, and we do that really by making vessels vastly more efficient. So we were founded back in 2014, 10 years ago, and with the realization that conventional electric or conventional boats are not that efficient. So at the time, our founder Gustav, he had a summer house in the archipelago, and he used to travel there with his this boat. And when he was there, he used to pop by a local ice cream store on one of the islands and buy ice cream for his kids. And that detour cost him 50 euros worth of gasoline, and the ice cream was like 5 euros. So when he summed up his fuel bills in the end, he realized that his boat used 15 times more fuel than his car per mile.
Mm-hmm.
And that led to the realization that, okay, in order to make a really good electric boat, you need to make it vastly more efficient. Otherwise, you would drain the battery too quickly. So this was when electric cars started to become a bit mainstream, really making the first inroads in the market. And he realized that, electric cars is pretty easy. You can just take you still have your set of wheels, and you can put a battery in there, and then you're good, right? But with boats, you really need to lift them out of the friction of the water. And the only way to do that is using hydrofoils, which are basically under the water.
Mm-hmm. Yeah, we're going to speak more about hydrofoils later, but I wanted to ask you. So yeah, you said 2014. So this is kind of the year, as you said, where the Tesla boom kind of starts, where the whole EV pandemic, let's say, started. So again, can you briefly explain why go for something like hydrofoils instead of just building a regular electric boat? Because I was reading a lot of articles, and I pretty much stumbled upon the fact that pretty much you have no competitors. You're someone who is the innovator, you total innovator. You have no one on your side, pretty much. No one chasing you.
Yeah, well, we do have a lot of guys chasing at us at the moment, but I do agree with you that we're kind of ahead of the rest of them, and the reason is that we're serial production. We've built around 100 foiling vessels so far, and we're unique in that aspect. This electrification at sea is a really hot topic, but the thing is that in order to make an electric boat with both range and speed, you kind of need to reduce that friction, because if you would drop a conventional car battery inside a 25-foot electric boat, you would end up with 1/15 of the range of the electric car, because boats use so much energy when they go through the water and they displace these huge wakes. And the wakes you see behind boats, that's the testament of how energy thirsty they are, because all the power goes into pushing this water aside instead of actually propelling the boat forward. So we realized pretty early on that, okay, you actually need to kind of get rid of, we have to stay out of the water. We need to lift it up. And that invention is in itself pretty old. Hydrofoiling has been around for 100 years. It was super popular in Russia. Soviet Union had hundreds of foiling vessels. It's been popular in Italy, in Europe, and in the US too. So we've developed that concept quite a lot by using new technologies such as lightweight carbon fiber, a fully stabilized hydrofoil system, which uses sensors, kind of the similar sensors that you find in the drone industry as well. So we kind of baked this all together to make an electric boat that has both long range and high speed, and which uses 80% less energy than a conventional boat.
Amazing. So they're the huge power saving factors. We had a lot of people on this show and in talking about battery technology. Where are you guys currently standing on your battery technology? We see a lot of articles right now about solid state. What are your current solutions, let's say, and maybe like a future plans? And how efficient are those vehicles? How much do they consume? And yeah, how much, let's say, do they weigh compared to the regular boats?
Yeah. Right. So we have two product lines. We have the Candela C8 leisure boat, and then we have the P12 electric ferry. Right. So both for passenger transport and for the recreational market. And if we start off with C8, that's an 8.5 meter long boat, 27 feet, and it has a very, very small motor compared to what you would find in a legacy conventional boat. So usually you have a 350 horsepower outboard, a V8 on a boat that size. And we're pretty proud of having a motor that outputs around 100 horsepower, say 80 kilowatts for takeoff. And while we're flying, we draw around 25 kilowatts from the motor. So from that, so that's not much. Right. And one of the reasons is obviously hydrofoils, because they reduce the energy consumption by lifting the hull above the water. The other factor we have here is that we have a very light boat. So it's 1,750 kilograms, including batteries.
That's really good. Yeah.
Yeah, which is it's pretty neat, because a conventional boat would be at least 500, 600, 700 kilograms more. And then you add the gasoline to that. So we have a very light boat. And when we were talking about batteries, I mean, we have developed the whole boat, including the flight control system, makes the boat fly and stabilize in real time, the carbon fiber hull, the C-pod propulsion, which is the electric drivetrain. We don't develop our own batteries, so we buy the best we can sort of get in the automotive market. So in the C8, we use a Polestar 2 battery of 69 kilowatt hours, including the DC charging from that. So it kind of made sense to, not build our own batteries, because you can get pretty good stuff out there on the market.
Absolutely.
And also, when it comes to the ferries, where we use Kreisel Austrian batteries, if you remember those guys that electrified Arnold Schwarzenegger's Hummer back in the days.
Yeah.
So we use them, and the reason we use them is that in the marine industry you need to have certified batteries. So you can't just build your own batteries, and it takes a lot of manpower to sort of certify those, right? So there are currently quite limited options, but Chrysler are great batteries and with high energy density. And that said, in the future, where we have solid state batteries with maybe one could only hope for twice the energy density. That wouldn't mean so much, I think, for conventional electric vessels, because the range would still be very limited. But for Candela, that would mean that we could cover many other use cases. We could go across larger bodies of water. We could even do like travel between Stockholm and Helsinki, perhaps on one charge, and things like that, or across the Mediterranean in many places and so on.
Yeah, exciting stuff. And you mentioned Polestar as being your battery supplier. For our listeners who are more into cars, into automobiles, I mean, Polestar is also your, if I read correctly, your design team, right? They're designing your boats. They're
They're not
involved.
our design team, so we have designed the whole boat. We do have a cooperation with the C8, which is called the. First off, I should mention that they do supply the high voltage battery and the DC charging capability. And then in terms of design, we have a design cooperation on the existing platform C8 for the Polestar edition, where they have made bespoke seats and also curated the interior. So that's the sort of top tier Candela C8 configuration that you can get. But many brand alignments in terms of design, I would say the Polestar, I think they make the best looking cars out there, super exquisite cars with a sort of Nordic minimalistic twist to them. The Candela is very much into that as well. Our vessels, if you look at them from the side, they're kind of clean, and the reason for them being so clean is that we really have to keep the aerodynamic efficiency here, because once you start to fly, a lot of the resistance, the drag we face is coming from the air, and hence we want the boat as clean as possible. So you see all the cleats can be folded in, they're not protruding, and so on. And we also had a lot of CFD for the windscreen to computer fluid dynamics, just optimize that, right? So yeah.
So Mikael, let me ask you. I mean, you've definitely been into one of those boats, but historic listeners who haven't seen that in real life or haven't been on one, how does the boat actually rise up and fly? How does that look? How does that feel? Is it like secure? Is it, security wise? Is it good?
Yeah, it is. I think it is what people don't really understand before they tried it is that it's a vastly better experience than riding on a conventional boat, because in a conventional boat you have the slamming, you have the noise from this like 300 horsepower engine that just sits just aft of the aft sofa. So, and you're talking about decibel levels in the 80s, 90s, right? So basically you have to scream and shout in order to hear what
Mm-hmm.
people are saying on board. So conversation tends to die down after a while and just sit there. And then obviously you can get seasick because it's bumpy, you run into the waves and so on. So it's not a super pleasant experience, although
Mm-hmm.
a lot of boats cost huge fortunes, right? So we've tried to kind of do away with all these drawbacks. So once you hit the throttle full speed, what's going to happen is that the stream of water flows over the wing, creating a pressure that lifts you upwards, just like an airplane wing, right?
Mm-hmm.
So at a certain speed, in our instance, at 16 knots, the boat will start to slowly rise up of the water. Takes around 3 seconds. And then when you're popped out of the water, all the noise disappears.
Mm-hmm.
Suddenly just silent, and you don't feel the waves slamming against the hull. So it's a very tranquil experience and very silent. And you start to notice your passengers sort of relaxing. They're starting to talk to each other. They talk to you, and people are noticing things around the boat, like birds, nice houses on the seafront properties that they can look at, instead of just holding on for dear life. So I think that's the Candela experience. It's a bit of a magic carpet ride.
Wow, now that you're talking about it, I wish we would have done this podcast on C8 or P12, you know?
You know what? We should do that next time, because it's so silent that you can actually have a podcast on board.
Yes, let's run the next podcast on one of your boats once it freezes, once it starts flying. That's going to be amazing. And the scenery in the background, we had to pick a good location as well.
Yeah, great show.
Yes. So we've kind of briefly touched on that, the difference between normal boats, quote unquote normal boats, and compared to your solution. Let's maybe circle back to your models. We kind of briefly touched on your model line, but can you maybe a bit more, explain to our listeners what do you offer, how do they differ, their use cases, and so on?
Yeah. So the C8, our recreational craft, it's what you call a day cruiser. A bit counterintuitively, it's a boat that you can actually sleep in, because it has this cabin in the front. And then you have where you can fit, small family of 4 perhaps, right? Or 3 engineers. I think we've had 4 engineers there at a time.
Mm-hmm.
So basically a place where you can sleep. And there's also a lavatory there. And then in the aft, we have this big cockpit with a sunbed and seating for 6 people. So it's basically this boat that you can go out with, you can hang out for a day, you can even stay the night if you want to. Great for excursions. Has a range of 57 nautical miles, so that's around 60 land miles on one charge at 21 knots. And now this doesn't really sound much compared to a car. We're talking about ranges of like 300 miles there. But for a boat, that's 3 times what you would get in a conventional electric boat, even though they have much larger batteries, right?
Mm-hmm.
So that's usually enough to do kind of long range excursions. We've been this year we've crossed the Mediterranean from Spain to Africa and back on one charge.
Wow.
And yeah, and last year last fall we went to Finland from Sweden, using the existing infrastructure, and coming back the same day to Stockholm as well. So I mean, and that's a fun thing, because you think that there are no places to charge your boat, right? But there are a lot of marinas with 3-phase outlets out there. Every bigger conventional, like diesel powered boat, needs to be charged, because they have big batteries for various applications. So there's actually a decent charging network in most marinas for electric boats already.
Mm-hmm.
So that's a leisure boat. And then we have the P12 ferry, which is a bigger vessel. It's 12 meters long, 4.5 meters wide, a catamaran hull with foils. And that takes 30 passengers and some bikes and strollers and wheelchairs if needed. And it has a range of 40 nautical miles, which is quite far for an electric vessel, because you usually know the route. You can charge at each end station if you want to. And that boat has been running in Stockholm's public transport now for 8 months with very good results, very high uptime of around 98%. So technically it's been working, because this is the first boat that is in public transport. It's been working very well, retracting the hydrofoils 5 times every day, no battery degradation, and full house all the time. We've had full departures every departure, so it's been a very popular option to travel with within the public transport system. And the reason is that people cut their daily travel times by in half almost, because it runs from the suburb called Ekerö outside Stockholm to the central city, and it takes an hour by car, it takes an hour by traditional ferry, but with the P12 it only takes 30 minutes, because we get a permit to run quickly and fast inside the city center, because we don't create any wakes.
Okay, so public transport is definitely one of the use cases for P12, which is really interesting. Now that I'm thinking, I was in Stockholm 7 years ago, and it was a gorgeous city. Is it called like a Venice of the North?
Venice of the North.
Venice of the
Yeah.
North, yeah. So I can definitely see the use case. And I can only imagine in my head all the good things, all the excursions possibly where you can apply this technology, for example, in New York, visiting all the statues, I mean, so many possibly things that can be done in such a cleaner way and overall more efficient. So I
Yeah.
guess the market for you is, what would you say your biggest markets are?
Yeah, I mean, there are a couple of use cases of this vessel, right? So one of them is what we just touched upon, the urban transport use case. So everything from Stockholm to New York to Venice is a great point in
Mm-hmm.
case where you have a lot of vessels going back and forth between the airport and the city, and these waves create these boats create these huge wakes, which tend to erode the structures that the ancient houses sit on, and that's a huge problem. It's called motondoso in Venice. So wake-induced damage to the structures. And since we don't create any wake, I mean, you could have vastly faster transport there and also save the city. And that's one use case. So there's other cities. New York, you mentioned that's where we talk to a lot of stakeholders right now. And we recently signed a big deal in Mumbai, in India,
Mm-hmm.
where
Congrats.
thank you. 11 vessels, and those vessels will be primarily used to transport people from Mumbai to the new airport that's being built just across the bay. So instead of
Mm-hmm.
going around the bay, which can take several hours in rush hour traffic, we'll do that in 40 minutes or so. Yeah, so that's one case, the urban transport case, because if you look at cities around the world, I think the last 120 years have really belonged to the car and the automobile, right? And before you had combustion engines and cars and so on, buses, most of the cities that are on the water relied on some kind of waterborne transport to get people from point A to point B. I mean, if you look at Stockholm or Seattle, for example, you had these huge fleets. In Seattle, it was called the Mosquito Fleet, I believe, where they had hundreds and hundreds of vessels, big and small, shuttling workers to the factories and taking people from different parts. Then the car came. The car is much faster, and hence public transport developed on land instead of on the waterways. And now we're at this sort of interjunction where you have a lot of gridlocks. You can just see the bridge there behind you on the
Mm-hmm. Yeah,
wall,
yeah, yeah.
telling it you have these long lines, but the waterways are mostly unused and they just sit there. It's free infrastructure. So if you can use this technology to sort of harness the power of the waterways, you can do a lot of quick cross connections that weren't possible before, and add another layer of public transport to many cities. So that's one use case. But the other is obviously, you look at hospitality. I mean, you look at all the archipelagos around the world, to Stockholm, to the Maldives and so on, where we can also make a huge difference. And we also have super interesting news that will come out soon.
Absolutely. Okay, we're very excited for that. Yeah, I'm just thinking about us on the Mediterranean and all the countries that are kind of similarly shaped and placed. There's so many use cases potentially. We have a big problem in Croatia, for example, with the islands that are small and far. For example, hospital needs. When someone needs help, and that can be super great solution. And yeah, really, really interesting product you have there. wanted to maybe go back to the charging part. We haven't had anything similar on our podcast, so I have to ask you, how does it work? How are the chargers placed? What is the technology behind them? How is it similar to electric vehicles and so on?
Yeah. So the C8 works just like an electric car. It's like plugging in your Polestar.
Mm-hmm.
You have a charger and then you plug it in, and if you have a DC charger, we can charge up to 150 kilowatts. So
Mm-hmm.
you can do 10 to 80 in 25 minutes, which is pretty good. So you can drive for 2 hours, charge for half an hour, and then you're good again, right? And chargers. I mean, there are quite a lot of DC charging stations popping up right now along
Mm-hmm.
the west coast, for example. There's a network now, and then in Norway there are quite a few as well. There's also charging networks in the US. We have Aqua Superpower, which is one provider that is setting up their network in various countries. I'm not sure about Croatia, but I mean, as I said earlier, there are the three-phase connections in almost every marina around the world,
Mm-hmm. Mm-hmm.
and that makes overnight charging easier. I mean, the charging patterns they look a bit different for a leisure vessel
Mm-hmm.
car, because usually you return to the same place. You don't really often travel from one city to another. You kind of go out, you have fun, you go back right to your home ports. You often charge overnight in your home port. Now with
Mm-hmm.
public transport, you need somewhat of a bespoke system, but that is also a very great thing about the technology. We can use a regular DC car charger for the P12, so it can charge at 300 kilowatts. So if
That's
you have
amazing.
if you have a supercharger style charger, which is very common and quite cheap from the car industry, you can set that up in most marinas, because most public docks have some kind of shoreline connection, because you need to be able to charge the auxiliary batteries of a big vessel as well, right? So, I mean, it's basically to just buy that DC car charger and plug it in on the dock, and then you're good to go. There's no need to build specialized megawatt infrastructure. I think we've seen this in many countries, in Norway, for example, where they tried to go for conventional electric large ferries, and they've stumbled when it comes to the charging, because you can buy the ferry. It will have not as great range as a diesel vessel, but the charging is the tricky part, because you have to build that, and sometimes it costs more than the actual vessel.
Also, talking about technology, I'm guessing it must be. Is there less maintenance when it comes to electric hydrofoil in comparison to the gas boats?
Yeah, well, the same thing as with a diesel motor versus
Mm-hmm.
an electric motor.
Less
There are
moving parts in general, yeah,
Yeah,
less.
exactly. I mean, and the thing is with our solution, we have this Candela C pod motor. So basically, we have a pod motor that we move down below the water. So the electric motor is under the water, and then the high voltage cable goes down through the rudder. The good thing about this solution is that you don't have a mechanical transmission, so there's no maintenance of that, and no noise, because a mechanical transmission is always noisy, right? So no oil changes, no filter changes, no cooling fluid, because it's cooled by the flow of seawater. So yeah, much less maintenance. And then obviously the foil system is retractable. So once you're in the harbor, you just retract it. It's above the water line, so there's no marine fouling on it, no growth.
Also, looking at your board behind. I mean, my first thought was like equations, but now I see it's like a meaning numbers. But in my head, it popped out. You also developed your own engine, so C motor, right? Is a C pod, right?
Yeah,
Is
exactly.
your own solution. So why create something on your own? I mean, it's a big maneuver, but instead of taking something from the shelf, taking something that was also manufactured from someone else.
Yeah, good question. The thing is that we would have loved to do that, buy something off the shelf. The thing is that there's never existed an electric hydrofoil vessel before, so
Mm-hmm.
we're the first to build it. So hence there are no efficient electric drivetrains for hydrofoiling boats out there. You can't really buy a high power electric efficient pod motor. There's
Mm-hmm.
no one on the market. I mean, there are pod motors for slower boats. I think I've seen 5 to 10 kilowatt range of motors. And those motors have almost the same diameter as our C pod. So the C pod for the C8 is around 11 centimeters,
Mm-hmm.
in diameter and outputs almost 100 horsepower, right? So it's a very energy dense motor. And
Mm-hmm.
if you go for a market solution that is readily available, then those motors are the same diameter, but maybe like 10 kilowatts. So
Mm-hmm.
so there were
Yeah.
none. That's the
Yeah.
simple answer. Yeah.
Okay, amazing. So in-house technology, great markets, great potential. Also, I mean, you can be I mean, you are the pioneering in this segment, so you can also potentially outsource your engines in the future, your solutions, which can be amazing for your company. I was thinking when I'm thinking about scaling, what is a city like, let's say Venice, Barcelona? What do they need in their infrastructure to adopt Candela into their ecosystem?
Well, if you look at Venice, for example, it's mostly a political decision, right?
Mm-hmm.
From a technical standpoint, not much. I mean, you already have docks there in place. This is a fairly small vessel, the P12.
Mm-hmm.
It has a flexible bow ramp in the front, and that bow ramp is adaptable to dock heights from 30 centimeters high, basically a floating jetty,
Mm-hmm.
to a regular dock where big boats dock 2 meters high. So you don't really have to adapt that infrastructure. You would obviously need to build the charging infrastructure, but as I said, that's cheap. You can get away with a car charger for
Mm-hmm.
a few 10,000s of euros.
Mm-hmm.
So that upfront cost is very low. And then the nice thing about having a Candela fleet is that your operational costs will drop around 60% compared to diesel vessels per year. And if you look at the whole business case of a public transport fleet, usually a third of the overall cost are fuel.
Okay, so adoption time is it's not a big hurdle. It's something that can be done pretty much easily. As you said, it's mostly due to a decision to make. Okay, let's switch. Let's make a switch. Yeah, that's really good, really good. And yeah, we heard the costs are just gonna get cut. Now I'm thinking about the future of Candela. What can you tell me? Maybe it's a bit of a fictional question. Seeing Candela in the next couple of years, seeing Candela, let's say by 2030, what do you see? Where do you see it? What are you wishing for? If you can maybe reveal some secrets about your potential, features, something new that's brewing in the factories,
Yeah,
etc.
I think 10 years time, I think it's at this point it's a lot about scaling, right? So basically mass production. We've already started. We're building 8 vessels at the moment. I think one of the unique things with the Candela P12 is that it's a small unit, but it's designed to replace much larger vessels, right? So if you go for a system where you have 3 small vessels instead of 1 big, you can shuttle as many passengers or even more because more people would choose the waterways. That's a big problem today. For example, in Stockholm, you have around 10% occupancy rate on these big 300 passenger vessels, right? So they're almost running empty. 9 out of 10 seats are empty, right?
Mm-hmm.
So I think what we're doing here with the P12 is that it's a kind of one-stop solution in the sense that we have 3 different interiors, but the boat otherwise is the same. So we can mass produce them, and we can do so at a good price point for the operators. And then I think we can start to roll out these systems. So I think Mumbai will be first, and then we'll see some other systems that we haven't announced yet. But I think in 10 years' time, I think public waterborne transportation and waterborne transportation will be much more of a thing that we see in cities. Instead of seeing the waterways just being used for recreational purposes and the old big vessel, you will actually have sort of subways on the waters.
Mm-hmm. Okay, that's an interesting, yeah. I was reading something about I don't know if I read correctly about Lake Tahoe, Sydney, and San Francisco. Are those also the markets that are being potentially
Yeah,
looked at as something that's
yeah. I mean, we've sold a vessel to Lake Tahoe already.
mm-hmm,
So we do a sort of north-southern ski shuttle
mm-hmm,
because winters the roads are closed, so getting around the lake is at
mm-hmm,
35, 40 minutes across the lake.
mm-hmm,
That's going to be an interesting use case to sort of connect the north and southern part. And then you have obviously you have a lot of other places where we're going to roll this out in the coming years, and the largest of these ones we haven't announced yet.
Okay, okay, okay. We are excited for you. We wish you all the luck in scaling. And I've kind of exhausted all my questions. I would like us to move to the lightning round that I prepared for us. So if you could answer in a sentence or two or a few words. So that can be, if you want, I can start a bit. The first one, I have four of them. So the first one is most misunderstood thing about hydrofoil, in your opinion.
Wow, there's a lot of misunderstandings, or actually I would say curiosity.
Mm-hmm.
I think that the most common question we get is, can you make a bigger vessel?
Okay,
Yeah,
interesting.
so right, and I think that stems from the fact that when it comes to public transportation, people are used to these very large ferries, 300 passengers and more, right? And so what we're trying to achieve here is to teach people that, okay, we don't need a bigger vessel. We just need to rethink how mobility is done on the water. I don't think so many people would ask Volvo or Scania or Mercedes or any other bus maker if they could make a much bigger bus.
Yeah.
If you had a bus line with, say, half the number of units that you have today, but they are vastly bigger and nobody would travel with them, and the departures would be few per day, that would be a suboptimal system on land. And the same is true on the waterway. So if you can move to a system where you have smaller units, but much more frequent departure and faster travel times, that's a better system. But that's a learning curve, and
Mm-hmm.
kind of a mission we're on to explain that to people.
Mm-hmm. I mean, myself, as I said at the start of the interview, as a hydrofoil rookie myself, mine was safety. Just from the looking at it, mine was safety.
Yeah.
But as you said, it's something that's also totally misunderstood.
I think safety is also one of the questions we get, right? But yeah, I mean, you're flying 1.5 meters above the surface, right?
Mm-hmm.
So it's inherently very safe.
Mm-hmm.
I could just share a story. I did the very first software testing in the Candela C7, our first leisure boat model, back in
Mm-hmm.
2019, and I had my daughter. She was home from kindergarten at the time.
Mm-hmm.
And the mission was basically to crash the boat as many times as possible, because we were trying out the software. Crashing means that you ventilate the main foil and you go down, right? And
Okay.
so you crash from 1.5 meters height down into the water.
Okay.
So at the time, the software was very immature. So I had a bicycle helmet on my daughter's head, right? And then we did 50 crashes in a row, and she just wanted to do one more. And that's how you can do rapid prototyping in with the software in a hydrofoiling boat. I mean, you can't do that in an F5 fighter or a Boeing, right? I mean, you don't
Yep.
want to crash
Yeah.
that thing. But the thing is, crashing in a foiling boat is kind of uneventful. It's a bit fun.
Okay. So crashing the hydrofoil is actually an endless fun,
It
which
is
is
fun.
amazing. Moving on to the next one. One regulation you'd change tomorrow to accelerate clean ferries.
Yeah. Right. Then I would change the procurement processes because they're very often written for current vessels, right?
Mm-hmm.
So in many countries, at least Sweden and some other, you have usually the procurement rules are specifying how big the vessels are supposed to be. For
Mm-hmm.
example, 90 passengers, and we think they should look at, like, how many passengers do you want to move a day? I mean, you can
Mm-hmm.
either have one huge boat that takes 1,000 people, one departure a day, or you can have a fleet of 20 boats that depart every 5 minutes.
Mm-hmm.
And choose when they want to travel, right?
Mm-hmm.
So that's one. And also the procurement processes don't often focus on, energy efficiency, reduced travel times and so on, because that's not been possible before. So
Mm-hmm.
they have to be rewritten, I believe. So hence, we mostly sell to private operators and entrepreneurs that see an opportunity to sort of compete with the
Mm-hmm.
public transport system. So this needs to change.
Yeah, I feel like especially in Europe we have just a bit of a too much of everything. So we can all benefit from some deregulations, especially in these products that are, I mean, it's so at the first sight you can acknowledge that those are beneficial for the environment and for the whole transportation process.
Yeah, yeah, definitely. I do agree. I mean, regulation is not a bad thing. It's if it's done right. Obviously, we need that. But I think good procurement is sort of focusing on the end goal, right? I mean, what do we want? Do we want faster transport? Do we want a better solution? Then specify that, but don't go into the details. Obviously, right? I mean, it can be done in various ways.
Mm-hmm.
That is what fosters innovation, I think, and progress.
Yes, I agree. Moving on to the next one, this personal one, a quick one. Your favorite city to fly a C8 in and why?
Oh, I must say Venice, actually.
Venice?
It's been I've been there, I think 5 times now with the
Okay.
and, just, the canals and this unique environment, and,
Yeah.
we did have the mayor on board once.
Mm-hmm.
Flew into the harbor where there's actually a 3-knot speed limit, and the chief of police was in the harbor just saluting, right?
Okay.
The boat doesn't create any wake, and what they don't like is the wake, right? Because that messes up the houses. So that
Yeah,
was
yeah.
a magical experience. So I think that's my favorite so far. But then again, I think going forward, I think New York will be a fantastic place as well to show off the technology.
Okay, we will need a footage of you flying through Venice when we are gonna edit this
Yeah,
podcast and the
you got
small
it.
the shorts. um, and the last one, let's go again to the future. The next feature you're itching to ship.
Yeah. Well, I would say one personal favorite feature that I look forward to implementing one day in software is the what I would call the eternal wake mode. Basically, if you could have the C8, I'm thinking about C8 now, and then you want to go really far, you could sort of lock on to the bigger wake of a freight ship or a cruise ferry or something. These huge rolling wakes, and you could just do this perpetual surfing,
Mm-hmm. Yeah,
keep locked in that wake. That
yeah.
would be a cool way to piggyback off the fossil fuel vessels.
Sounds really cool. My question too, what about we had a lot of people on the show regarding solar energy. Is there any possibility of integrating one of your boats with solar panels? As we see the technology developing really fast, is there potential of extending the range? I mean, as we know, I mean, boats are sitting on the sun pretty much, and a lot of time in a nice weather.
Yeah, exactly. I mean, I think there's perhaps less of a use case for the public transport vessels, the P12, as
Mm-hmm.
for the C8. But I mean, if you would straddle the C8 with solar panels on the deck and so on, I think maybe you would get like a kilowatt of charging, perhaps. So it's not that much. But then again, boats are not used every day. So if you had that sort of feature there, it could definitely top itself up.
Like a slow charging.
I mean, we've all seen these promising solar cars.
Mm-hmm.
I don't remember what that Dutch outfit was named again.
There's Aptera are there from San Francisco. They're
Yeah,
solar.
yeah, exactly. They are a bit more extreme, but then you had this Dutch company as well that unfortunately went bankrupt. That also made very nice solar panels. I think in the end, it's a kind of trade-off since the boat needs to be very light.
Yeah.
Adding solar panels would add weight. What's the real benefit of having them? I mean, it would be a cool feature. It would also be relevant if you would sort of stay out back, sort of with your boat and hang out for a few days where there's no grid connection. Then you could definitely benefit from it. So let's see. Who
Yeah,
knows?
yeah. Who knows? And we are concluding here. Thank you so much, Mikael, for joining us. And the whole team of Candela for showing us how to make a big change in clean transportation. Wish you all the luck, and we hope to host you again soon with for the round two with your new features, new stories, new markets, and so on, so on. So yeah, thank you once more, Mikael.
Thank you so much for having me on the show, and look forward to doing this on the P12 next time.
Absolutely, yeah, I forgot about that. Yeah, scratch everything I said. Yes, let's do it on P12 next time. Thank you so much.
Thank you.